So, hello everyone, good day, and I hope you're doing well. And I hope also na nasubaybayan ninyo o watch tong mga videos na akong ipang-upload and gi-attach sa inyong LMS. It is because dili na to magets or masabtan ni nga mga topic or kani nga nagsunod nga topic if wala to ninyo na watch to ang previous nga video. It is because connected lang to sila. So karon let's discuss the last topic under lecture 8, no, the design of ABE waste treatment and management systems. So we all know na ang AWMS is composed of different functions katong productions, collection, storage, treatment, utilization, mato siya. So these functions are carried out by planning, applying, and operating individual components. So ang component can be a piece of equipment such as kanang ginagamit ito nga pump, structure, or such as sewage or waste storage tank, or an operation such as kanang mag-composting tank. So if combination man, dapat it allow flexibility na need to efficiently handle all forms of waste na ato ang ma-generate. So all components should be designed to be simple, manageable, and durable, and they should require kanang dapat low maintenance lang. And in this topic, components will be discussed and will describe the functions that we need to accomplish. So for production, components that affect the volume and consistency sa tuong agricultural waste na na-produce are included in the production function. So roof gutters and downspouts and diversion to exclude clean water from areas of waste are examples of components that reduce the volume sa tuong waste material nga need na to i-manage. So fences and walls that facilitate the collection of waste confine the cattle. So thus, it increase the volume, di ba? So roof runoff management should be diverted from feedlots and manure storage areas unless it is need for some use. So such as dilution sa water for waste storage ponds or treatment lagoons. So this can be accomplished by roof gutters and downspouts with underground or open channel outlets like aning naa sa picture nga gipakita. So naasay cases na ang gutters and downspouts dili na need if the roof drainage will not come into contact with areas accessible to livestock, di ba? So there are the area of roof that can be served by a gutter and a downspout, like kanina sa figure. Downspout system is controlled by either the flow capacity sa gutter, no, mo na itong ginatawag na channel flow, or the capacity sa downspouts, mo na ito ang ginatawag sa na orifice flow. So, yeah. So the gutter's capacity may be computed using the Manning's equation. So here we have a procedure for the design of roof gutters and downspouts. So for step 1, compute the capacity of the selected gutter size. So this may be computed using the Manning's equation, like I said earlier. So using this recommended gradient, no? So gradient, gradient of 1/16 inch per foot, no, mo na ang rule of thumb na siya na ginagamit for computing the gradient or slope. So and the Manning's roughness na coefficient of 0.012. So this equation can be expressed. So Q or the capacity, QG or the capacity of gutter, with unit nga cubic feet per seconds is equal to 0.01184 times the cross-sectional area of the gutter and then multiplied to R, or the uh, cross-sectional area over the wetted perimeter of the gutter, expressed in inches. So for step 2, compute the capacity of downspout. So using an orifice discharge coefficient na 0.65, the equation may be expressed as follow. So capacity of downspout is equal to 0.010457 multiplied to the cross-sectional area sa downspout and then multiply sa head. So for step 3, determine whether the system is controlled by the gutter capacity or downspout capacity and adjust number of downspout if desired. So we have the number of downspout, then capacity sa gutter over the capacity sa downspout. So if the number sa downspout is less than 1, the system is gutter capacity controlled. If it is equal to or greater than 1, the system downspout capacity controlled unless the number of downspout is equal or exists the ND, or the number of the downspouts. So the above, or the early mentioned na ko nga procedure, is a trial and error. So it's trial and error process. So the different sizes of gutters and downspouts should be evaluated along with the multiple downspouts to determine the best gutter and downspout system to serve the roof area involved. So for step 4, we have the determine the roof area that can be served based on the following evaluation or equation. So area of the roof served is equal to Q, or the capacity of systems, either QG or QD, whichever is smallest, and then multiply to 3,600 over dP, or the 5-minute precipitation for appropriate storm events inches. So sometimes kaning P is ginhatag ni siya, computed already. So essentially, all livestock facilities in which the animals are housed in open lots, or the manure is stored in open in the open, must be dealt with or run off. So clean runoff from land surrounding sa mga livestock facilities should be diverted from barns, open animal concentration areas, and waste storage or treatment facilities like aning nasa picture or sa figure. So runoff from feedlots should be channeled into waste storage facilities gamit ning collection gutter. Mao ni nga mga diversion of clean water around sa feedlot. And then next, we have the collection. So livestock and the poultry manure collection often depends on the degrees of freedom that is allowed sa atong animals. So if ang animals are allowed the freedom of movement within a given space, the manure produced will be deposited randomly or bisan asa. So components that provide efficient collection of the animal waste include paved alleys, gutters, and slatted floors with associated mechanical and hydraulic equipment. So alleys are paved areas where the animals walk. So generally they are arranged in a straight lines between animal feeding and bedding areas. And then sa slatted floor, animals hoof works that manures through the slots into the alleys below. So the manure is collected using or through flushing and scraping sa alleys. So sa scrape alleys and open alleys na ay duha na siya kakain sa scraper to clean alleys, no, like aning gipakita sa figure na mechanical scraper, and it is dedicated to a given alley. So it is a propelled using electrical drives na attached sa cables or sa chains. So naasad tay tractor scraper, ang tractor scraper na can be used in irregularly shaped alleys and open areas where mechanical scrapers cannot function properly. So it can be a blade attached to either sa front or sa rear or sa tractor, or a skid steer tractor that has a front mounted na bucket. So the width sa alis depends sa desire sa producer and sa width available sa ato ang equipment. So scrape alis width typically varies from 8 to 14 feet for dairy and beef cattle, and 3 to 8 feet naman na pod sa swine or sa mga poultry. So ang alis can be cleaned by flushing. So grade is critical and can be varied between 1.25 and 5%. No? So iyang slope, no? Vary ang slope. It may change for a long flush alis. So alley should be level perpendicular sa center line. So the amount of water used for flushing is also very critical. So an initial flow depth of 3 inches for underslot gutters and 4 to 6 inches sa open alleys is very necessary. So the length and width of flush alleys are also factors. So most flushed alleys should be less than 200 feet long. So the width generally varies 3 to 10 feet depending sa animals. So underslot gutters and alleys channel width should not exceed sa 4 feet. So sa width sa open flush alleys or sa cattle is frequently 8 to 10 feet. So flush alleys and gutters should be clean at least kaduha sa isa ka adlaw. For pump flushing, each flushing event should have a minimum duration no mga 3 to 5 minutes. So we have here some tables, no. So kaning table 10-1 and table 10-2. So nag-indicate sila og general recommendations for the amount of flush volumes. Either for swine, for dairy, beef feeder. So we have here also the flush tank volumes and discharge rates. So that's all. So on and so forth. Table 10-3 also gives the minimum slope required for flush alleys and gutters. So this figure 10-4 and figure 10-5 illustrates flush alleys. No? So these are the example for dairy flush alley and for swine flush alley. And several mechanisms are used for flushing alleys. So the common rapidly empties large tanks for water or use high volume pumps. May several kinds of flush tanks na ginagamit. So kaning nasa figure, no, gipakita. So one known as the tipping tank, pivots or shaft as the water level increases. At a certain design volume, the tank keeps emptying the entire amount in a few seconds, which causes wave the runs, so the length of the alley. So some flush tanks have manually operated gates, and these tanks are emptied by opening either sa valve or sa standpipe. So naay pipe plug or naay flush gate. So float switches can be used to control flushing devices. So another kind sa flush tank ginagamit sa principle na nagagamit og principle sa siphon. So kanina tank sa ang water level naga-increase siya to the point na ang head pressure sa liquid na overcomes the pressure of the air trap uh, in the siphon mechanism. So at this point, ang tank rapidly empties, so causing the desired flushing effect. So most flush systems use pumps to recharge the flush tanks or to supply the necessary flow if the pump flush technique is used. So another for collection, we have the gutters. So gutters are narrow trenches used to collect animal waste. They are often employed in confined stall or stanchion, dairy barns, and in some swine facilities. So naa siya different types of gutters. We have the gravity drain gutters, step dam gutters, scrape gutters, and the flash gutters. So first, we have the gravity drain gutter. So, it is a deep, narrow gutters na can be used. Magamit siya in wine finishing building like aning na sa picture. And these gutters are the lowest elevations of the pen. So, the animal traffic moves the waste to the gutter. So, the gutter fills and it is periodically emptied. So, gutters that have the YUV or rectangular kanang cross-sectional shapes are used in farrowing and nursery swine facilities. And these gutters can be drained or be gravity drained periodically. And then we have the step dam gutters. So step dam gutters were also known as the gutters or the gravity flow channels. So nag-provide ni siya og alternative for collecting the dairy manure like aning nasa figure. So a 6-inch high dam holds back a lubricating layer for manure in a level. So a flat bottom channel. So manure drops through a floor grate or slats and flows down the gutter under its own weights. So the gutter is about 30 inches wide and the steps down to deeper cross channel below the dam. So we have these scrape gutters. These are frequently used in a confined mga usually ginagamit niya siya sa mga confined stall dairy barns. So ang gutters are 16 to 24 inches na iyang laparon and ang ihang ang kalalumon is 12 to 16 inches. And generally do not have any bottom slope. So they are cleaned using shuttle stroke or chain and flight gutter cleaners like aning na asa picture. So electric motor driven shuttle stroke gutter cleaners na siya mga pedals that pivot on a drive rod. So the drive rod travels alternately forward for a short distance and then backwards for the same distance. So the paddles are designed to move manure forward and the forward stroke and to collapse on the drive rod on the return stroke. So this action forces the manure down the gutter, no, using the shuttle stroke gut. And then we have the flash gutters. So, mga narrow gutters it is a narrow gutters can also be cleaned by flushing. So, flash gutters are usually a minimum of 2 feet depth on the shallow end. So, the depth may be constant or increase as the length of the gutter increases. The bottom grade can vary from 0 to 5% depending or storage requirement and clean out technique. So flushing tanks or high volume pumps may be used to clean flush. So for collection again, waste materials are worked through the slots by the animal traffic into a storage tank or alley below. So most slots are constructed of reinforced concrete like aning na asa figure or picture. However, some are made of wood, some made of plastic or napoy aluminum. So they are manufactured either as individual unit or as gangs of several slots. So common slots openings range from 3/8 inch to 1 and 3/4 inches. So depende sa animal, no? So depende sa animal because animals nagaproduce sila of different, di ba nga kanang type ani solid, no, different types sa waste. Different forms, di ba? So for swine, openings 3/8 and 3/4 inch are not recommended. So basin or maybe kaning mga slot no kasi naa siya kanang effect or disadvantage if gamiton nimo ni nga 3/8 and 3/4 inches no anong dili siya i-recommend. So basin malusot ang iyahang tiil, di ba? Ni mga anang instances. So slots are designed to support the weight of the slots plus the live loads no sa animals, humans, and the mobile equipments. So expected for particular facility. So reinforcing steel is required in slots to provide the needed na strength or load. So now let's proceed na sa storage. So for storage, atong waste must be stored so that it can be used if ang weather condition nato is appropriate or makip nato siya if atong weather is inappropriate. So storage facilities for waste of all consistencies must be designed no to meet the requirements of a given enterprise. So dapat ma-anticipate na nato if liquid, slurry, or solid ito ang mga waste. No, dapat na atay facilities or storage facility for a given all consistencies sa to ang waste na ma-produce. So determining the storage period for storage facility is crucial to the proper management of an agricultural waste management systems. If too short a period selected, the facility may fail before the waste can be used in an environmental sound manner. So if too long naman po, a period may result in an unjustified expenditure sa atoang facility. So daghang factors na na-involve in determining the storage period. So they include the weather, the crop growing season, the equipment availability, soil, the soil condition, labor requirements, the management flexibility, no? So given when atong waste utilization is by land application, dapat atong storage facility must be sized so that it store nato ang waste during sa non-growing season or dili pa time for land prep or land application, no? So a storage facility that has a longer storage period generally will allow more kanang flexibility in managing sa tuang waste no to accommodate the weather variability, equipment availability nato, equipment breakdown, and overall na operation management. So storage facilities for solids manure include the waste storage ponds and the waste storage structures. So for waste storage ponds are earthen impoundments used to retain manure, bedding, and runoff liquid. So solid and semi-solid manure placed into a storage pond will most likely have to be removed as a liquid unless precipitation is low or means of draining sa liquid is not available. So the bottom and entrance ramp should be paved if emptying equipment will enter the pond. So waste storage structures can be used for manure that will stack and can be handled by solid manure equipment, handling equipment. So these structures must be accessible for loading and hauling nato nga equipment. They can be open or pwede siya covered. So roof structures are used to prevent or reduce excess moisture content. So open stacks can be used in either arid or humid na climate. So seepage and runoff must be managed. So structures for open and covered stacks are often have the kanang kahoy, no kahoy or napud siya reinforced na concrete or napud siya concrete block na sidewalls. So the amount of bedding material is often dictates whether or not the manure can be handled or as is solids. So in some instances, manure must be stored in open stacks, fields. So runoff and seepage from these stacks must be managed to prevent movement into the streams or other surface or other bodies of water. So kaning figure na akong ipakita shows variations solid manure storage facility. So kaning sa A is solid manure stocking facilities, and then kaning sa B is the roofed solid manure storage. So for solid waste storage ponds and structures may be designed correctly to ensure desired performance and safety. So considerations include the kaning material selection, control of runoff and seepage, necessary storage capacity, and a proper design of agricultural structural components such as walls, and roofs. For material selection, these are materials na suited for long-term exposure sa tong animals without rapid na deterioration. So structural grade steel is also used, but it corrodes and must be protected against the corrosion or be periodically replaced. So similarly, high quality and protected metal fasteners must be used with timber structures to reduce corrosion problem. So the primary materials used in constructing timber structures for solid storage are pressure treated or rot resistant wood and reinforced concrete. So seepage and runoff, which frequently occur from manure stocks, must be controlled to prevent the access into surface and body of water or sa groundwater. So one method to control is to channel the seepage into storage pond, and at the same time uncontaminated runoff such as that from the roof and outside the animal housing and lot area should be diverted around the site. So concrete ramps are used to gain access to solid manure storage areas. Ramps and floors of solids manure storage structures need to be designed so that handling can be safely operated. So the ramp and slopes of 8 to 1, horizontal to vertical or flatter are considered na safe. So for slopes steeper than this are difficult to negotiate. So concrete pavement for ramps and storage units should be rough finish to aid in traction. So ramps need to be wide enough that equipment can be safely backed and maneuvered. So factors to consider in the design of storage facilities for solids include type, number and size of animals, number of days storage desired, and the amount of bedding that will be added to the manure. So equation can be used to calculate the manure storage volume. We have the VMD is equal to the number of 1,000 pound animal units by animal type, and then multiplied to DVM or the daily volume of manure production for animal type, and then the D is the number of days in storage period. So the bedding volume to be stored can be computed using this formula. So we have the bedding volume is equal to FR, the volumetric ratio, multiplied to weight of bedding used for animal type, and then the AU or the number of animal, animal unit, and then the multiplied sa D or the number of days stored over the BUW or bedding unit weight. So, muna siya. So, using the recommended volumetric void ratio of 0.5, the equation becomes, so BV is equal to 0.5 times WB times AU times D over the BW. So, allowance must be made for the accumulation of precipitation that may fall directly into the storage. So, contaminated runoff should be handled separately sa solid manure and sa ato ang storage facility. So uncontaminated runoff should be diverted from storage unit. For liquid and slurry manure can be stored in a waste storage ponds or in above or below ground tanks. So, isa sa problem sa solid manure kay ang pag-separate sa manure from bedding na dapat i-consider jud sa planning and designing. So, solids generally can be suspended with agitation before unloading, but it involves cost in time, no, need ka og labor, and also need ka og energy. So another options allow solids to accumulate if the bottom is already cleaned. So this require a paved working surface for equipment. So earthen storage is frequently the least expensive type of storage. However, certain restrictions such as limited space, availability, high precipitation, water table, permeable solids, or shallow bedrock can limit the types of storage na i-considered. So storage are earthen basins designed to store wastewater and manure. So storage pond are earthen basin designed to store wastewater and manure. So natay figures diri nga ako ang gipakita. So sa figure 1 is the cross section of area storage pond without a watershed. So please study na lang sa kaning figure, no, kanang iyang freeboard nga minimum pila na ang iyang depth 25 year 24 hours storm. So please take note about this. And then the B is the cross section of waste storage pond with watershed. And then kaning C is the waste storage ponds. So they generally are rectangular, but maybe circular or any other shape that is practical for operation and maintenance. So commonly na ginagamit nila. So the inside slopes ranges from 1.5 to 1 horizontal vertical to 3 to 1 3 to 1. So the combined slopes inside plus outside should not be less than 5 to 1 for embankments. So the soil safety and operation and maintenance need to be considered in designing the slopes. So the minimum top width of the embankment should be 8 feet. However, greater widths should be provided for operation of tractors and spreaders and portable pumps. No. So storage ponds should provide capacity for normal precipitation and runoff, so less evaporation. So during the storage period, so pumping platforms and ramps are used to unload storage ponds. So method of removing solids from should be designed for the storage ponds also. No? So if ang waste will be pumped, adequate access must be provided thoroughly na ma-agitate ang contents sa pond. So a ramp should have slope, no, nga 8 to 1 or flatter, and be wide enough to provide maneuvering room for unloading equipment. So pond liners are used in many cases to compensate for site conditions or improve operations of the pond. So concrete, geomembrane, and clay linings reduce permeability and can make an otherwise unsuitable site acceptable. So geotechnical design and construction guidelines for waste impoundment liners for detailed clay liners is naa siya kanang gina-follow nga standard. So concrete also provides a wear surface if unloading equipment will enter the pond. So kaning naa sa figure, no, sa figure or attached figure represent various kinds of storage ponds and tanks, no. So mo niya ang mga layout for waste storage ponds. So naatay cross section along the ramp, and cross-sectional of AA. So for liquid manure can be stored in above the ground. So like aning nasa figure, no? Or below the ground, kaning nasa figure nga 10-18 mo ni above the ground and kaning 10-19 is below the ground. Below the ground tanks. So liquid manure storage tanks can be constructed of metal, concrete, or pwede sa wood. So below the ground tanks can be loaded using the slatted floor, push-off ramps, gravity pipes, or gutters, or pwede sa ramps. So above the ground tanks are typically loaded by a pump moving the manure from a reception pit. So tank loading can be from the top or bottom of the tank depending no sa iyang consideration. So naay factors na desired agitation, minimize pumping head, weather conditions, and system management. So storage volume requirements for tanks are the same as those for ponds except that provisions are normally made to exclude outside runoff from other storage tanks because of the relative high cost of storage. So of course, if plans include storage of outside runoff, accommodation for its storage must be included sa tank volume. So now let's have the design considerations. So tank material types, no, primary materials used to construct manure. The manure tanks are reinforced concrete, metal, and wood. So such tanks must be designed by a professional engineer and constructed by experienced constructor. So, a variety of manufactured, modular, and cast-in-place tanks are available for commercial na mga suppliers. So, a determination must be made that the site conditions are compatible sa imong design assumptions on which the design is based or ibutang. So structures can also be designed on an individual site-specific basis. So ang cast-in-place reinforced concrete, the principal materials used in below-the-ground tanks and can be used in above-ground tanks as well. So tanks can also be constructed or precast concrete panels that are bolted together. So other above ground tanks are constructed of metal. Glass fused steel panels are widely used. Such tanks are manufactured commercially and must be constructed by trained crews and other types of metals panels. So sizing, yes, the liquid waste storage pans and structures should be sized to hold all the time manure bedding, wastewater from milk house, flushing, and contaminated runoff that can be expected during the storage pond. So the kaning equation can be used to compute the waste volume. So waste volume is equal to TVM, or the total volume of manure for storage period, equals to DWM, or the total volume of manure storage, and or equal to TBV, the total bedding manure for storage period. So on solid manure storage, material is applicable to these items used for liquid manure storage. So all possible influences such as internal and external hydrostatic pressure, flotation and drainage, live load equipments and animals, and dead loads from covers and supports must be considered sa ato ang buhaton na design. So pan sealing pan sealing waste storage pan must not allow excess seepage. So the soil in which pan is to be must be evaluated and, if needed, tested during the planning and design to determine the need for an appropriate liner. And now let's move on to treatment. So in many situations, it is necessary to treat agricultural waste before nato gamiton, before final utilization. So the purpose of treatment is to reduce pollution potential of the waste through biological, physical, and chemical processes using such components as lagoon, oxidation, leaches, and composting. So this type of components reduce nutrients, destroy the pathogens, reduce the total solids. Composting also reduces the volume of waste. Treatment also includes any step that might be considered for pre-treatment, such as solid separation and drying, dilution that repairs the waste, for facilitating and other functions. By their nature, treatment facilities require higher level of management than that of the storage facility. So because yeah, so first we have the anaerobic lagoons. So anaerobic treatment of animal waste helps to protect water quality by reducing much of the organic concentration known ang BOD, COD of the waste. So anaerobic lagoons also reduce the nitrogen content of the waste through ammonia volatilization, effectively reduce animal waste odors if the lagoon is properly managed. So for the design, the maximum operating level of an aerobic lagoon is a volume requirement plus the depth requirement. The volume requirement is the sum of the following volumes. So first, the minimum treatment volume, the manure volume, wastewater volume, and the clean water, and then the sludge volume. So the depth requirement is the normal precipitation less the evaporation on the lagoon surface. So polluted runoff from watershed must not be included in the lagoon unless a defensible estimate of the volume or the volatile solids can be made. No? So runoff from a watershed such as a feedlot is not included in the lagoon because loading would only result during the storm events and because the magnitude of the loading would be difficult if not possible or possible to estimate. So the combination of these volumes and depth is illustrated sa kaning figure 10-21. So anaerobic waste treatment lagoons are designed on the basis of volatile solids loading rate or the VSLR per 1,000 cubic feet. So the volatile solids represent the volume of solid material in waste management, a waste that will decompose as opposed to a mineral, so the inert fraction. So the rate of the solids decomposition in an aerobic lagoon is function of temperature. Therefore, the acceptable BSLR varies from one location to another. So the minimum treatment volume or the MTB represents the volume needed to maintain the sustainable biological activity. So the minimum treatment of BS can be determined using the equation. So MTB is equal to TVS over the BSLR. So waste volume or the WV should reflect the actual volume of manure, wastewater, flash water that will not recycled, and clean dilution water that is the lagoon during the treatment period. So the treatment period is either the detention time required to obtain the desired reduction of the pollution potential of the waste of the between land application events, whichever is longer. So state regulation may govern the minimum detention sa time. So generally, the maximum time between land application event determines the treatment period because this generally exceeds the detention time period. So to get the wastewater volume treatment period, we have equals to TBM plus TWW and then plus the CW or the clean water added during the treatment period. So, as the manure is na-decompose na siya sa anaerobic lagoon, only part siyang total solids is ang na-reduce. So, some of the total solids is mineral material that will not or dili siya ma-decompose. And some of the volatile solids na is nag-require siya og kanang taas nga time para ma-decompose. So, kaning nga materials, mo na ang gina-refer nato nga sludge. no? So gradually ma-accumulate ni siya sa lagoon. So to maintain the minimum treatment sa sa volume or the MTB, the volume of the sludge accumulation over the period of time between sludge removal must be considered. So lagoons are commonly designed for 15 to 20 years sludge accumulation period. So the sludge volume or the SB can be determined using this equation. So SB is equal to 365 days times AU times TS times SAR times the T. So total solids can be obtained from the previous nato nga mga topic na na-discuss, no, kung saan pagko sa TS. So sludge accumulation ratio and then or the SAR, kung dili siya available sa beef, it can be assumed similar sila sa dairy. So the lagoon volume requirements are for accommodation of the minimum treatment volume. So the sludge volume and the waste volume for treatment period. So to get also the lagoon volume requirement, we have equals to MTB times SB and then plus MTB plus SB plus WB. So the minimum acceptable depth of an aerobic lagoon is 6 feet. So but in colder areas or colder climates, at least 10 feet is recommended to assure proper na operation sa odor control. So the design height sa embankment sa mga lagoon may be increased by the amount needed to ensure that the design elevation is maintained for settlement after settlement. So this increase should not be less than 5% of the design fill height. So the minimum top width of the lagoon should be shown, no, or ipakita aning table 10.-5. Although a width of 8 feet and less is difficult na to construct. So the combined side slope of settled embankment should not be less than 5 to 2, 5 to 1. So horizontal and vertical. So the inside slope can vary from 1 to 1 for excavated nga slopes to 3 to 1 na flatter where embankments are used. So a lagoon should be constructed to avoid seepage and potential groundwater pollution. Care in site selection, soil investigation, and design can minimize the potential of these problems. If overtopping can use embankments failure, an emergency spillway or overflow pipe should be provided. Sludge removal is an important consideration in the design. So this can be accomplished by agitating the lagoon and pumping out the mixed sludge or by using a drag line for removing floating or settling sludge. So this figure shows a two lagoon systems. So kanina lagoon is ginatawag ni siya anaerobic lagoon recycle system. So for management, anaerobic lagoons must be managed properly if they are to function as designed. So specific instructions about lagoon operations and maintenance must be included in an overall waste management plan nato that is supplied to the decision maker. So normally, ang aerobic lagoon is managed so that the liquid level is maintained or at below the maximum operating level niya. Like atong ipakita nako sa figure kaganiha about atong mga lagoons, no, na design. So mas maayo na i-lower na to ang minimum sa treatment level sa end sa iyang treatment period. So isa sad na sa good practice na mag-install og minimum treatment or maximum sa iyang level sa operation. Kay by this ma-anticipate nato ang maximum tolerance niya og ang iyang capacity. So the minimum liquid level in an aerobic lagoon before waste are added should coincide with the MTV. If possible, a lagoon should be put into service during summer or allow adequate development bacterial populations. So a lagoons operates more effectively and has fewer problems if loading is by small, no, frequent day inflow rather than sa dinaghan tapos infrequent slug loads. So dagang problems associated with lagoons are related sa pH, no? So ang optimum pH is about 6.5. If magbaba ang pH below sa level, ang methane bacteria are inhibited by freely hydrogen ion concentration. So ang mga kasagaran cause why mag-low ang pH sa mga anaerobic digestion is the shock loading of organic material that stimulates the facultative acid problem bacteria. Kanang mag-load ka og dinaghan, no, pina-abrupt na dinaghan. And then add hydrated lime or lye if pH is below 6.5 and add 1 pound per 1,000 square feet daily until pH reaches 7. So lagoons are designed based on given loading rate. If an increase in number of animals is anticipated, sufficient capacity to handle all the expected waste load should be available. The most no, the most common problem using lagoon is overloading, no, overloading, which can lead to others malfunctioning and complaints. When liquid removal is needed, the liquid level should not be dropped below the MTB plus the SB levels. So, yeah. Sometimes, sa mga operators, gusto nila is, ang lagoon is, lagoon effluent as a flash water. So, to polish and store water for this purpose, waste storage pan can be constructed in series with the anaerobic lagoon. So, the capacity of the waste storage pan should be sized for the desired storage volume. So, ang minimum capacity of waste storage pan is the volume of rainfall, no? The RFD and the runoff. So odors and level of ammonium nitrate will be more effectively reduced if nag-follow ta sa proper o standard na sizing, kanang standard na mga i-follow dapat sa manage as kuan sa tong management. So we have here the aerobic lagoons can be used if minimizing odors, no, kanina sa figure. So these lagoons operate within a depth of range 2 to 5 feet to allow more oxygen extrinsic that is necessary for the aerobic bacteria. So the main disadvantage of this types of lagoon, kaning aerated, is that energy requirements to operate the mechanical aerators are high level of management ang gina-require. So the type of designs includes 1 pound of oxygen transfer to the lagoon, lagoon liquid for each pound of BOD added. No? So, na two kinds of mechanical aerator ang ginagamit. So, the surface pump and the diffuse air systems. So, the surface pump floats on the surface of the lagoon, lifting water into the air, thus assuring air-water mixture. So, the diffuse air system pumps air through water, but it's generally less economical to operate than the surface pump. So aerators are designed primarily in their ability to transfer oxygen on the lagoon liquid. Of the secondary importance is the ability of the aerator to mix or disperse the oxygen throughout the lagoon, where the aerator is intended for minimizing odors. Complete mixing is not consideration except as it relates to the surface area. In some situations, sufficient space is not available for a lagoon for treating animal waste, and odor control is critical. One option for treating animal waste under these circumstances is the oxidation ditch, like aning as a figure or picture. The shallow continuous ditch generally is an oval layout. It has a special aerator spanning in channel. So the action of the aerator moves the liquid waste through the channel and keep the solids in the suspension. Because of the need of continuous aeration, this process can be expensive. To operate oxidation ditches should not be designed by a professional engineer nga familiar aning process flows. So we have the drying and dewatering. So dried or dewatered manure solids are often sold as a soil conditioner or garden fertilizers. So these solids may also be used as a fertilizer sa agricultural land. They are high in organic matter and can be expected to produce odors if moisture is added and the material is not re-dried or composted. Because the water is not removed, no, the concentrations of some nutrients and salts will change. Dried manure should be analyzed to determine the nutrient concentration before i-apply siya sa land. So composting converts an organic waste material into a stable organic product by converting the nitrogen from the unstable ammonia form to more stable organic form. The end result is the product that is referred to use the raw organic material and one that improves soil fertility, tilt, water holding capacity. In addition, composting reduces the bulk organic materials to be spread, improves its handling properties, reduces odor, fly, and other vector problems, and can destroy weed seeds and the pathogens. So composting is the aerobic biological decomposition of waste or organic matter in its natural process that enhance the accelerated by the mixing of organic waste with other ingredients in prescribed manner for optimal microbial. So there are basic methods of composting. We have the windrow, the static pile, and the in vessels. No, so wind method involves the arrangement of compost mix in long, narrow, and piles of windrow. No, like aning naa sa figure or picture. To maintain an aerobic condition, the compost a mixture must be periodically turned. So this exposes the composing material to the air. So it keeps the temperature from getting too high, no, more than 170 degree Fahrenheit. So the minimum turning frequency varies from 2 to 10 days depending on the type of mix, volume, and ambient air temperature. As the compost ages, the frequency of turning can be reduced. So the width and depth of the windrows are limited only by the type of turning equipment used. So turning equipment can range from front-end loader to an automatic mechanical turner. So windrows generally na siya 4 to 6 depth and 6 to 10 feet na wide. So these are some of the advantages and disadvantages of windrow method. So for advantages, rapid drying with elevated temperatures, dried product resulting in easier product handling, ability to handle high volumes of material, good product stabilization, and low capital investment. And for disadvantages, not space if no space efficient or not space efficient, high operational cost, piles should be turned to maintain aerobic conditions, turning equipment may be required, vulnerable to climate changes, other release on turning of compost, and lastly, the large volume of working agent might be required. So for static pile method consists of mixing the compost material and then stacking the mix on perforated plastic pipe or tubing through which air is drawn or forced. So forcing air through the compost pile may not be necessary with small compost pile that are highly porous or with a mix that is stuck in the layer, no, with highly porous nga mga materials. So the exterior of the pile generally is insulated with finished composed of the other nga mga materials. In a non-layered operations, the materials to be composted must thoroughly blended before kanang pile placement. So, i-mix siya pag-ayo before siya i-pile. So, the dimensions of the static pile are limited by the amount of the aeration na pwede i-supply sa mga blowers and stacking characteristics sa isa ka waste. So, composed mixture height generally ranges sa mga 8 to 15 feet lang. And the width is generally twice the depth. So, individual piles generally are spaced about the half of distance of the weight of the height rather with forced airs. So, air movement through the pile occurs by suction or through vacuum or positive pressure na force. So through perforated pipes or tubing, a filter pile or material is normally used to absorb odor if air is sucked through the pile. And kani sad siya ang mga advantage o advantages of in using the static pile na method. So advantage is natay low capital, high degree of pathogen destruction, good odor control, and good product stabilization. While sa disadvantage, not space efficient, vulnerable sa climate impacts, difficult to work around perforated pipe unless recessed, and then operating cost and maintenance on the blow. So the in-visa method involves the mixing of manure or organic waste with a bulking agent, in a reactor, building container, or vessel. So like anin naa sa picture. And nag-involve ni siya og addition sa controlled amount sa air over sa specific detention. So, kaninya method na siya potential nga makaprovide og taas nga level sa process sa control sa iyang moisture, sa aeration, sa temperature, can be maintained with some of more sophisticated units. And mausad ni siya ang advantage and disadvantages in using the vessel method. So first, the advantage is space efficient, good process control because of self-containment, protection from adverse climate conditions, good odor control because of self-containment and process control, potential for heat recovery dependent on system design, can be designed as a continuous process rather than a batch process, and sa disadvantage, high capital cost for sophisticated units, lack of operating data, particularly for large systems, careful management required, dependent on specialized mechanical and electrical equipment, potential for incomplete stabilization, mechanical mixing need to be provided, and less flexibility in operation mode than with other methods. And then for methods of selection, no? So mo ni ang atong i-consider when magpili ta. So magpili ta kung unsa nga composting method ato ang gamiton. So first is the operator management capability, equipment and labor availability, site features, compost utilization, climate, cost, and of course the compost utilization kung para unsay mohang kanang target, no, for utilization of that composted nimo nga manure. And then siting and area consideration, dapat consider na to ang wind direction, topography, groundwater protection, area requirements, and existing area. And then for compost utilization, no, finished compost is na-share ka ng variety of ways, no, nga pwede na to siya gamiton. But primarily, we know nga ang kanang compost na product, no, or composted na to ang product is for primarily used is for fertilizer supplements and soil conditioner. So compost improves soil structure and soil fertility, but generally contains too low of quantities of nitrogen to be considered, no, the only source sa isa ka crop nitrogen. So nutrients in a finished compost will be slowly released over a period of time, thus minimizing the risk of nitrate leaching and high nutrient concentrations sa surface. So if nakay good quality nga compost, it can result sa product nimo and can be pwede nimo siya mabaligya, pwede can be marketed to home gardeners, no, sa mga landscapers, vegetable farmers, garden centers, mga nursery greenhouse, no, katong mga more on mga farming, no, ug nagagamit og mga compost soil. So for compost mix design, composting of organic waste requires the mixing of an organic waste with amendments or bulking agents in the proper proportions to promote aerobic microbial activity and growth. To achieve optimum temperatures, the following must be provided in the initial compost mix and maintained during the composting process. So the proper proportion of waste amendments and bulking agent is commonly called, no, moonang recipe. So, a composting amendment is any item added to the compost mixture that alters the moisture content, no, na CN ratio or pH. So, materials are suitable for us as a composting amendment. So, crop residue, leaves, grass, straw, itong mga hays, and peanut hulls are some just a sample that may be available sa tuang farm. And others na sa ginagamit og sodas, wood chips, shredded paper, and cardboard na pwede po available and inexpensively outside the sources. No? So, for compost design parameters, to determine the recipe, the characteristic of waste and amendments of working agent must be known. So, kung unsa to ang imuhang mga ibang butang no, sa imuhang isagol-sagol na waste. So, the characteristics that are most important in determining the recipe, the moisture content, the wet basis, carbon nitrogen content, and the CN ratio. If any two of the last three components are known, the remaining can be calculated. So the carbon to nitrogen ratio, or the CN ratio, the balance between carbon and nitrogen in the compost mixture, is a critical factor for optimum microbial activity. After the aerobic waste and compost ingredients are mixed together, organisms multiply rapidly and consume carbon as a food source and nutrients to metabolize the build proteins. So the CN ratio of the compost mix should be maintained for most compost operation between 24 to 42 to 1. If the CN ratio is low, loss of nitrogen generally occurs through rapid. So kaning table 10.6, the typical carbon to nitrogen ratios of common composting amendments. So isa sa factor na dapat nato i-consider is the moisture. So moisture, microorganism need moisture to convert the carbon source to energy. So bacteria generally can tolerate a moisture content as low as 12 to 15%. However, with less than 40% moisture, the rate of decomposition is very low. No? So, kung greater than 60% moisture sad, the process turns from one that aerobic to one that is anaerobic. So, anaerobic composting is less desirable because decomposes more slowly than aerobic. So, sa pH sad, is self-regulating, is not concerned with composting or cultural waste. Bacterial growth generally occurs within the pH, so 6 to 7.5. Maunan dapat dili siya magbaba ng range. So sa fungi growth usually occurs within the range of 5.5 to 8.5. The pH varies to the compost mixture, and during the various phases of tend produces putrid odors. So the finished product should result in a manner that has a low moisture content composting process. So the pH is the compost mixture is difficult to reduce once the composition is started. So optimum pH control can be accomplished by adding alkaline or acidic minerals to the initial mixture. So the determination of the compost mix design, or kaning tawag na recipe, is normally an iterative process of adjusting the CN ratio and moisture content by the addition of amendments. If the CN ratio is out of the acceptable range, the amendments are added to adjust it. So kanina chart is the compost mixture design flow. So the CN ratio is again checked and the process may be repeated. So after a couple of iteration, the mixture is normally acceptable. So kanina figure is a mixture design process flow chart that outlines the iterative procedure necessary in determining the compost recipe. So we have the step 1, step 2, and then the step 3. So we have here the steps in design, follow the mixture design process flow chart. First, step 1 is determine the amount of bulking agent to add. So the process normally begins with determining whether or not a bulking agent is needed. In addition of the bulking agent, it is necessary if the raw waste cannot support itself, or if does not have sufficient porosity to allow internal air movement. So a small field trial is the best method to determine if ang amount sa working agent is required ba siya. So, for example, gamay lang sa imong gamiton before nimo siya idinaghanon. To do this, a small amount of raw waste should be weighed and incremental quantities of bulking would be added and mixed until the mix has the structures and porosity nga desired. So the wood chips, the bark, shredded rice are example of bulking agents and commonly used. So for step 2, calculate the moisture content of the compost mix after the need for and quantity of bulking agent have been determined. So the moisture content of the mixture of raw waste should be calculated. So we have here the formula, no, the percent moisture content with bases, no, like na discuss na nato in yung previous na to nga mga topic. So we have also here the formula for the percent moisture of the compost mixture in wet bases. So ano siya nga formula. So note lang, to avoid confusion and repetition of the combination of excreted manure, bedding, water, and bulking agent will be referred to us as the compost mix. No? So the general equation for the moisture content of the compost mix mo ning percent moisture o kanina diri ang formula. So for continuation, if the moisture content of the compost mix is less than 40%, adding an amendment is necessary to raise the moisture content to an acceptable level. So water in the amendment that is generally added to raise the moisture content, but an amendment that has higher moisture content than desired moisture content of the compost mix is acceptable. So if the moisture content compost is above 60%, the addition of amendment is necessary to lower the moisture content or below 60%. So sometimes nagagamit sila og straw, sawdust, wood chips, and leaves, no, for to do that, to lower the moisture content. So the CN ratio of the compost mix is calculated from the CN ratios of the waste. So the working agents and the amendments, so typical values for various selected agricultural waste. Katong na-discuss na to sa previous na mga chapters. So the CN ratio for various waste products and amendments are also nasa table na ato ipakita later. Itong pakita na ako while ago. So this is the formula on how to calculate the CN ratio. So percent of C or the carbon dry bases is equal to 100 minus percentage of the Fs or the fixed solids over 1.8. So for dry weight of carbon is equal to Vs over 1.8. And then the Cn ratio is equal to percent of carbon over the percent of nitrogen, or equals to dry weight sa carbon over the dry weight sa nitrogen. So the CN ratio and nitrogen content of the manure and other amendments are highly variable, using local values for CN ratios and nitrogen for testing the compost constituents is highly recommended. So the general equation for estimating the CN ratio of the compost mix is given by Rm is equal to WCW plus the weight of the carbon in bulking agent plus the weight of the carbon in amendment over the weight in nitrogen in waste plus the weight in nitrogen in bulking agent plus the weight in nitrogen in amendment. So the weight of the carbon nitrogen in each ingredient can be estimated using the following equation. So mao ni no kaning gipakita. So if the CN ratio is calculated in step 3 is less than 25 or more than 40, the type of amendment to add the compost mix must be determined. For a compost mix that has a CN ratio below 25, an amendment should be added that has a CN ratio higher than desired CN. So for the compost mix that has CN ratio of more than 40, an amendment must be added that the CN ratio that is less than the desired CN ratio. So Moni determine the amount of amendment, if any, to the add compost mix that will result in initial CN ratio that is 25 and 40. So Moni nga equation can be used to calculate the way of amendment to add achieve desired of the CN ratio. So after the amount of an amendment to add has been determined to correct the CN ratio, the design process then returns to step 2. Now, if no change is necessary in step 2, step 3, and the compost mix design process is complete. So for compost mix that has a CN ratio of more than 40, a carbon-less amendment such as fertilizer can be added to lower the CN ratio. No, like kung diingan ka ganiha nga naay mga uh, materials, organic materials na pwede i-add to lower the CN ratio. So within the acceptable range, this is the possible case, special case, the following equation can be used to estimate the dry weight of the nitrogen using this formula, so or equation. So WND, or the dry weight of the nitrogen to add to mix. So I have here an example, the side example, on how to mix on compost mix. So, dili na ako ni-discuss, and please study na lang kung ang process, ito mga steps na i-follow in solving this design example. And for composting operational considerations, so the landowner should be provided a written set of instructions as part of the waste management plan. So kaning mga instructions should be detailed, and the operation and operation requirements are necessary for successful composting operation. They should include the compost mix design, kutang recipe, method or schedule returning or rating, instructions on monitoring sa imong compost process, and the long-term storage compost. So the final use of compost would be detailed in waste utilization plan. So mo ni ang mga consideration, operational consideration, composting time, temperature, moisture, and the odor. So for compost process steps, first is preconditioning of the material, so as needed lang. So mixing of the waste with bulking agent or amendment, aeration by forced air or mechanical turning, moisture adjustment, curing, drying, bulking agent recovery, and last one is the storage. Another one for solid waste is the mechanical separation. So mechanical separation, animal manure contains material that can be often be reclaimed. Much of the partly digested feed grain can be recovered from the manure of poultry and livestock fed high grain rations. So this material can be used as the feed ingredients for another animal. And then settling basin used in the association with livestock operation is a shallow basin or pond that is designed for low velocities and the accumulation of settled materials. So most readily settled solids will settle from the flow, and the velocity of the liquid is below 1 to 1.5 feet per second. And then we have also the dilution and the vegetative filter. So, kanisa, pwede sa siya magamit in getting or separating the solid waste, from its liquid waste. And then for transfer, manure collected from within a barn or confinement area must be transferred to the storage or treatment facility. In this simplest system, the transfer component is an extension of the collection method. So we have the reception pits, gravity flow pipes, push-up ramps, picket dams, pumps, and other equipments. And then for utilization, it is a function in a waste management system employed for beneficial purpose. So the typical method is to apply waste to the land as a resource nutrients for plant growth and organic matter to improve soil tilth and water holding capacity. So it includes nutrient management, land application equipment, land application of municipal sludge, and also biogas production. So for ancillary components, fences are important components in some agricultural waste management systems. They are planned and designed in accordance with conservation practice standards of fencing code. So every livestock and poultry facility experience lost animal by death, regardless of the method used. So the disposition of dead animals should be accomplished in sanitary manner and in accordance with all the state and local laws. So if possible, human waste should be treated in municipal facilities designed to provide proper treatment. However, in many areas or rural areas is dili ini siya possible. So safety must be a primary consideration in managing animal waste. It must be considered during sa atong planning and designing, dapat naka-include yun siya. So during the actual operation of handling waste, the operator must be made aware of the safety aspects of any waste management systems components under consideration. So safety accident involving waste management may be the result of poor design and or construction, lack of knowledge or training about the components and their characteristics, poor adjustment, poor judgment, carelessness or lack of maintenance, and lack of adequate safety device such as shield, guard, rails, fences, or mga warnings na mga sign. So for confined area, kaning mga area ang sa manure nga can accumulate when manure is stored in environments that do not adequate ventilation and underground covered waste storage tanks. No? So daghan silang mga produce nga mga chemical or mga baho nga may be harmful sa locals or sa landowner or sa mga tao. So dapat na ang mga rules na i-follow, mga signboard if necessary to warn the people about the danger na pwede nila makuha dira nga area. And then the above tanks can be dangerous if access is not restricted. No uncontrolled access can lead to injury or death from falls or ladders and death from drowning if someone is mahulog dito as a storage tank. So dapat na ay mga rules should be na informed. So lagoons and ponds and liquid storage structure present the potential of drowning animals, humans if access is not restricted. So dapat na ay mga floating crust, mga capable supporting persons weight, na provide or mga warning signs na dapat kuan nga na ay mga lagun dito. So all equipment associated with waste generates such as spreaders, pumps, conveyors, and tractors can be dangerous if not properly maintained. So operators should be thoroughly familiar with the operator's manual, no, sa itong dapat na mga buhaton, dili dapat buhaton. So equipment should be inspected frequently and service is required. So dapat na yung mga guards and safety shields na i-keep in place sa pumps, around sa pumps, hoppers, or sa mga spreaders, or sa tanan ng mga equipment na pwede maghatag og danger.